This video is going to be from my advanced chemistry class. I'm going to be covering chapter 16, concentration of solutions. This is going to be the mathematical part of this chapter. I kind of covered briefly theory behind it. Okay. And lock and load. Okay. Now, concentration of solutions is basically quantitatively how many moles of solute, okay, are in a liter of your solution. So how many moles of the solute are in the total solution? And the new conversion factor that we're going to use in this is called molarity. Its symbol is M. And anytime you see M, you have to define the units, and the units are going to be moles of solute over per 1 liter of solution. Okay. That's when you see, so if you're doing a problem and you see 5.25 big M of NaCl, you always want to define molarity. You do not want to use the big M generally most of the time. You're going to define this as the number of moles of sodium chloride per liter of your solution. And the answer is that it's 5.25 moles are in 1 liter of solution. So whenever I do that problem, whenever I give you M, you want to define what M is. And this will be used in dimensional analysis as a conversion factor. Okay? And with that, let's see, there's 4 basic types of problems. So types, I'd say number 1 would be going from grams to liters. Number 2 type, you could be converting from liters to grams. So these two are just directly on your mole map. Number 3, finding molarity. Whenever you have a problem where it asks you to find a molarity, you want to define what big M is. You'll find the moles divided by the liters if it's X. Okay, and number 4 will be dilution problems. If you see a dilution problem, you'll see the word dilution, although it can be in a molarity problem. But if you see the word a dilution problem, and the thing about dilution problems, if you have 2 molarities and 2 volumes, the solution to a dilution problem is very easy. It's just like gas laws when we use Boyle's law. It's molarity 1 times V1 equals molarity 2 times V2. And you just create a list and plug it in. And in a dilution problem, this is the one time you really don't have to define M. You can just put M in, and the unit M cancels out. But in all the other problems, you always want to define M. All right. Let's start off with the worksheet I gave you. And you'll see all these different problems in that worksheet. So that'll be our start. And see, the marker's bleeding through, so I'm going to kind of go over to a black pen. I was going to try and get a little bolder with the marker, but it's not, kind of too much. Okay. Number 1. And there might be one other thing I'd like to show you. And this was the mole map. just keep this aside. A concept map for dimensional analysis. If you have moles of X, which things can you go to? Through a balanced equation, you can always go to a different substance, so you can go to moles of Y. And for that, you would use a balanced equation. We're not really ready to cross this line in this chapter. That's when we would have reactions happen. Everything right now is not a reaction. Okay. Normally, we've used this for moles to grams. So I can go from grams of X to moles of X, and moles of Y to grams of Y. And my link between these two are the molar mass, which you find on the periodic table. So that would be the grams per moles. And over here we'd have the molar mass of Y, different substance. Again, you'd find this on the periodic table, the number of grams per moles. Okay. We just got done doing gas laws. You can go from a mole to a liter of gas. And we could use PV equals nRT and solve for N to get to liters of gas. And we can go PV equals nRT for a different gas and go to liters of gas Y. And this is gas X. These would be at any condition. We could also use that 22.4 at STP, but solutions are down here. Now we can only use 22.4 and PV equals nRT for gases. Everything here is a solution, so we can go to a mole, but now it's going to be to a liter of a liquid and of an aqueous solution as opposed to a gas. So up here is a gas, down here would be a liter solution. And our new conversion we just learned was big M. So the conversion will be moles of X per liters of solution. And then over here, I could go to liters of solution. This one would have Y in it. This one would have X in it. And I'd use molarity, big M, of Y, so it'd be the number of moles of Y over liters of solution. And conceptually, we're going to go from liters to moles, back and forth we can go. And if I'm going to go from gram to a liter, there's not a conversion between grams and liters. You always have to go through moles. So go gram to mole, mole to liter. So in this chapter, in this worksheet, we're going to be doing a lot of looking up of different molar masses. Okay? Alright. And what to remember is just your steps involved in dimensional analysis. Okay? If I wanted to, I could create a list as a problem-solving strategy. My list, I'm given 3.88 grams of K2CrO4. Okay. I want to know question mark liters of the solution. And I'm given 2M. Now when I give you 2M, I don't mean to give you 1 sig fig. Giving you, make sure I'm standing there. Giving you 2M, I'm going to automatically assume that's 2.0, and that will be moles per liters. So whenever I see that 2M, I'm going to define that as 2 moles of K2CrO4, that's the solute, per 1 liter. And that becomes our conversion factor. Now, I'll look at the mole map as I do this problem. So I'll refer up here. looking at this problem, okay, dimensional analysis, I always want to put where I'm going on the right. And where I'm going to is the question, how many liters of solution are there? Okay, I start with my starting point is 3.88 grams. K2CrO4. Okay, and then I'm going to use dimensional analysis to get from grams to liters. So if I go over to my concept map, and this is reactions, I'm going to stay on the left side of this map. I'm starting at grams and I'm going to liters. So I can see the map will help me see that I have to go from grams to moles and then moles to liters. And then I'm home. Okay, so dimensional analysis. I start with grams on top, so I want grams on bottom. And this is K2CrO4. The unit I need to go to is moles. In chemistry, you're always using moles as a step-off unit. Okay, this is a conversion factor, which I have to look up. Grams cancels out. I don't even need to put the numbers in yet to solve the problem. My next step is I go from a mole of K2CrO4 to a liter of solution. Then equals. This step is what's new to us. Moles per liter is molarity. Now, as a problem-solving simplification, I created a list on the left. I put liters on the right, so I take that off my list. I started with grams, so I take that off my list. Now I know that I use 2 moles per liter. Now that is a conversion factor, so I don't want to start with the conversion factor. I don't want to start in the middle of this problem. I want to start at the beginning and end at the end, liters. So where does the 2 moles per liter? That's right here. How many moles per liter are there? There's 2.0 moles per 1 liter. Okay. What I need to look up for is my molar mass on the periodic table. So I might have scrap paper over here and I'll say K equals 2, chromium equals 1, oxygen equals 4. So K is 2 times 39.1, so you get 78.2. Chromium is 52, so you get 52. Oxygen is 16, 4 times 16 is 64. Okay, so you get 0.2. The unit is grams per mole. 4. Okay, and not doing very good tonight with math. 9. So you get 194.2 as a molar mass. So I always put units on it, grams per mole. That goes in here as my conversion factor, 194.2 grams per 1 mole. Now on my calculator, I plug in 3.88 divided by 194.2 divided by 2, and your answer equals 1.0 liter. When I did this problem, I did not expect to come out to exactly 1.0. Totally coincidence that I use those numbers. I just picked them randomly. Okay, so that's our first type of problem. That first type of problem was grams going to moles. Okay. I'm going to do a similar problem now. It asks you how many grams, so I'll create a little list here, question mark grams. And it's now still dealing with K2CrO4. It means you don't have to look up the molar mass twice. I need to make 1,000 milliliters. And it's 0.25. Now for the M, I substitute moles per 1 liter. And it's K2CrO4. Now, What do I put on the right? I have a nice list here to keep me organized. I put grams on the right, K204. Okay. On the left, I'm given 1,000 milliliters of solution. So if I go to my mole map, I'm starting with liters now, ending at grams. The last problem, grams to liters, grams to moles to liters. Now I got liters to moles to grams, but it's milliliters. Okay? So I need to take a milliliter and convert it to a liter. I don't want to start off with the conversion factor, the 0.25. Your conversion factor is always going to be in the middle of the problem. Okay, so I've already used 1,000. I already placed the grams. The only thing I have is the molarity. So just looking at units, not numbers. I want to go from a milliliter to a liter. And that's a solution. Then I need to go from a liter in my solution, and I'm going to go to moles. Okay, that's my conversion factor. And the units will cancel off. And then I have moles on top, so I want to cancel moles. So it goes on the bottom. And that's going to be K204. I want to make sure I label K204. And then grams of K204. Okay. I now see that my final unit is grams, so I have the problem skeleton laid out. So conversions, there's 1,000 milliliters in 1 liter. This being 1,000 and that being 1,000 are strictly coincidental. Okay, this 1,000 is because 1 liter equals 1,000. Okay, next step, moles per liter. That's my molarity, 0.25 moles per 1 liter. In the last problem, the molarity was inverted. Now the moles are up top. It's just the nature of the problem. Okay, that's why we use dimensional analysis. We're not memorizing how to do, a specific problem. Each problem might be a little bit different in nature, but if we use the process, everything works out great. This next conversion is the molarity. It's the molar mass, which you already found out that 194.2 grams is equal to 1 mole. So I take my calculator, 1,000 divided by 1,000 is 1, times 0.25, times 194.2, and the answer is 48.6. Now please, I only give you answers for you to reference, for you to compare to. So don't put equals 48.6 if it doesn't. Actually push this into your calculator and make sure it equals 48.6. Then compare it with the answer I'm giving you. I'm giving you an opportunity to see if your answers are right or wrong. Okay, I'm going to do number 3, and I kind of did number 3, not with us thinking that we're on COVID-19, but if I asked you, I'd say describe how you make a half a liter, 0.5 liters of 2 molar solution of sugar. So you might be a lab assistant, but I haven't told you where to go, like what unit. So I'm trying to do this like you're my lab assistant and you're going to make a solution on your own. Okay. Things I have is I have 0.5 liters. Okay. And I have 2 moles per 1 liter. That's the molarity. Okay, so my question is, I don't know where to go. Well, it's sugar. And what I would do is say, what I'm really asking you to do is to weigh out a certain amount of sugar. So what I'm looking for you to find is the number of grams of sugar. And a little trick is you can see my answer at that point, that it's in grams. So if we're going to make the solution, we're going to put grams of sugar on the right, and sucrose, C6H12 0.06. No, that's glucose. Double it. C12H22 O11. Okay. Where do I start? Okay. I ended at grams. So I'm going to start at 0.50 liters. Now in some of these, I made these worksheets years ago, and I wasn't really looking at sig figs, so I would say I'm not really looking at one sig fig. I should put 0.50 and 0.20 molar, so I'm getting better at that. Okay. Liters is my starting point, so I'm here, liters. I want to go to grams, so it's liters to moles to grams. I can always look at this mole map. It's great to look at. It keeps you going where you need to go. Okay, if I put liters on the bottom, whenever you don't know where to go, you got to go to grams. The secret is, in your mole map, moles is always in the middle. So if you're unsure where to go, you usually convert into moles. Liters to moles. 2 moles per 1 liter. That's the molarity right there. You notice I'm not putting a big M in here. That's a little m. You don't want to put a big M in dimensional analysis because it ruins the conversions. Okay, always define molarity. Okay, I'm at a mole, I want to go to a gram. I always want to write down where I'm going to because that keeps me directed. So I want to go from moles, that cancels out, to grams.